Happy Monday, everybody. Good to see you. Sorry I wasn't able to be with you on Friday. We had a substitute come in and had prior obligations I had to be at, and I apologize. So hopefully you had a good weekend. Beautiful, right? Got outside, maybe did some outside sciencing. And if not, so be it. The world is at your fingertips, right? You can do whatever you choose to do, however you feel it. So hopefully, I'm hoping that some of you did some sciencing at home or came up with some ideas. Today, we're going to take a dive. We're going to go diving. Well, not really. We're going to make a Cartesian diver. And some of you are like, well, what the heck is that? Well, let's do a little experiment before we do our make. Let's talk about, things that have density, and let's talk about air and compression, and we'll do that a little bit, and then we'll do our little demonstration. So I guess what we can start with, this is part of the materials that you're going to need for the Cartesian diver. Bottle, right? And we need the lid. We need the lid to this. So if you toss the lid out in your bottle, then you're going to have to go find a bottle, but we're going to need the lid. So you need a water bottle, right? Obviously, you're going to need some water, right? We're going to take some water. So I got my water. You're going to need some rubber bands, okay? Rubber bands. Probably, if you could find ones that are small, they'll work better with this experiment. A larger one, you're going to have to wrap it more times, and sometimes little hands have a hard time wrapping a rubber band. So I would look for the small ones. Paper clips. You need some paper clips. Probably about 4 to 5, 5 to 6, however you meant, handful, whatever. A straw, right? Now I have the big bendy straws. Preferably, how are you? You're going to need about 6 inches, but we'll get to that in a second. So grab some straws. If you don't have straws, this will work with any type of tubing. You can use tubing as long as there's enough space in the tube for air to get inside. So if you have some rubber tubing, or you want to find some tube, that's fine. Straws will work best with this. I have seen this experiment done with a pen cap. So, just you take the pen off the cap and you use this part right here. I've seen it done with this. This is a neat little challenge that you can try. So again, using materials that you'd find in your own home. So I'm using straws. You can find a pen cap. Essentially, you need something that it can have air get inside of it. Okay, so if you cut off the bottom of a pipette or something, anything or any material that has the ability to store some air inside. Okay, so first things first. Oh, this isn't needed for the experiment, but I grabbed these. So again, we're using things in our own home. I grabbed these packets, and this is going to be for my demonstration, and then we'll build the Cartesian diver here in a second. So first things first, I'm gonna put my water, and of course I'm going to spill it everywhere because that's customary, right? I'm literally spilling water everywhere on the floor just because I can't pour it out of this. All right, so if you see, I'm pouring my water inside my bottle here and onto my table. So when we do this experiment, obviously we're making a mess, right? So that's okay, no big deal. So the idea here is to get the water to the very tip top of your bottle. Now, so if you notice, I spilled water. Now, I don't know what's going to happen here, but we're going to try it out. I spilled water, but essentially when you do this experiment, you're going to need water to go all the way up to the very top here, okay? Now, the Cartesian diver was named after a man named Descartes, okay? And he was a mathematician and a philosopher, but this experiment is named after him because a Cartesian diver shows buoyancy and density at its finest, okay? So if we take a little packet here, now this is soy sauce. We ate at our favorite Chinese restaurant over the weekend. So I had a couple of packets left over. So I have 2 here, and there's going to be something interesting that's going to happen here. But if you notice, so there's liquid inside the bottom part here, and then there's nothing in the top part. So first question is, what's taking up that space up there, right? First question, right? So if you said air, you're right. So you have a liquid that's taking up the space, and then you have air or gas. Gas is the oxygen inside that packet. So if I squeeze it, my packet becomes swollen at the top, and that bubble or that pocket of air becomes smaller. Okay, so very interesting, right? So what we're going to do is we're going to stick those packets inside our bottle. Okay, there goes one. We're going to fold up the second one, put it inside. All right, now I'm going to cap off my water bottle. Okay, now you want it to be as tight as you can, because what we need to do is we need to squeeze this. So if you could see, both of my soy sauce packets are in there. What's going to happen is I'm going to apply an amount of pressure to my bottle. Okay, I'm going to squeeze it. That's how I'm going to apply pressure. So when I squeeze it, the pressure that I'm applying is pushing against those packets, which in sense is pushing against the air pocket inside those soy packets, making the bubble smaller, which means something is going to happen. So let's see what happens when I squeeze my bottle. Let's see if you can see it. Ready? I'm going to squeeze as hard as I can. Okay. Nothing's happening. All right. So there's a reason why that's not happening. Hey, Rowan. Ro. So I need to call on my trusty assistant here because he's going to help me out. Hey, Ro, I need some water in there, buddy. So what we're going to do is we're going to need to put water in our bottle, right? Okay, so fill that up in the sink in the laundry room. Okay. All right. All right, so Rowan has come back with the water. Thank goodness for Rowan. Okay, thank you, buddy. So we're going to fill that up. To the very tip top. Then I'm going to put my lid back on. All right, let's get back to, okay, so there's my 2 packets. So I'm going to squeeze my bottle because I want to force air in there. Okay, so watch what happens. Squeezing. One sank. Did you see that? Look, one sank when I squeeze it, one didn't. So I released the pressure and it floated right back to the top. So let's try it one more time. So I'm squeezing, I'm applying pressure, which is making the packet of soy sauce more dense. So watch, squeeze, one floats, one doesn't. So here's the $1 million question. Why did one packet float and one didn't? One sank. So there's the question I want you to answer. So there's a reason. It has to do with the packet and the bubble inside of the soy packet. Okay, so that being said, I'm going to take my soy packets out and we're going to make a Cartesian diver. So you're going to be able to do this at home. Okay, simple experiment. You don't need a lot of materials. Okay, you're going to take your straw. Okay, now you need a pair of scissors to cut your straw, and you're going to cut off that bendy end, or you want about 6 inches. Okay, now we're going to do 2 things here. I'm going to cut off a little more here because my bottle is a little bit smaller. So if you have a big bottle, if you're using a 2-liter bottle for this, and you fill your 2-liter bottle all the way to the top, you're going to use all 6 inches of your straw. Okay, but because our bottle is a little bit smaller, we're going to use a little smaller straw. So I'm going to cut 6 inches in half, which is 3. Right? There you go. 3 inches, right? What you want to do with your straw is you want to fold that in half. Just like so. Okay? Just like that. And to keep it together, this is where the rubber bands come in. Okay? So you're going to take your rubber band and you're going to wrap it around the bottom of your straw. Now, again, like I said, the smaller the rubber band, the easier it is, right, because you don't have to wrap this around so many different times. Okay, so there's what that'll look like. So you have your straw folded in half with rubber band at the bottom. Now the rubber band is going to cause the straw to have a little bit of weight to it. Okay, now if you put this in your water, there's a good possibility it may sink, it may float, but you're going to have to test that out. So my soy packets are still inside my water bottle. So my Cartesian diver, because that's now what we've created, is a Cartesian diver. I will say, chances are your diver is not going to sink because it needs a little bit more weight to it. So to add weight to your Cartesian diver, this is where your paper clips come in. Now, you notice you want that hook end of the paper clip to be pointing down, not up. You don't want to hook your paper clip on this way. You want to hook it down. Okay, so I'm going to show you. Just like that, you're going to slide that right into the rubber band. Okay. Now, in my test, I think 3 paper clips. So there's 2. I think 3 paper clips works the best. I'm going to add a third right there. So I have 3 paper clips on my Cartesian diver. Now, essentially what's going to happen is when we put our diver in the bottle, okay, now he's floating around in there with my soy packets. All right, he's in there. You're going to put your lid back on your water. Okay, so not only do I have my 2 soy packets in there, but I have my Cartesian diver. He's floating, right? So 2 things are going to happen when we squeeze the bottle. Either your diver is not going to go down, which means he's not dense enough, right? Dense items always fall or sink in less dense items. So in this instance, right now, the packets of soy sauce and our Cartesian diver are less dense than the water. We need to make them more dense. So to get them to be more dense, we need to apply pressure to the outside of our bottle. So let's see what happens. I'm going to turn it so that you guys can see right there. Let me squeeze my bottle. Oh, there goes my diver. Look, squeeze, he went to the bottom. And if I release the pressure, he goes right back to the top. So we've applied pressure, which made the diver inside more dense because air is squeezing itself up inside that straw, causing him to sink. Now, if you do this with a bigger bottle, remember I said you want to use the longer end of the straw. Make the straw about 6 inches, but I only cut it at 3 inches. So there's an extension to this that you can do as well. You can make a game out of this. So if you were to make your diver and add a little hook on the end and put some rings in the very bottom, maybe the plastic tops from your bottle, you know, maybe that ring right there, if that drops in, or you need something that sinks to the bottom, you could create a game of this. So it's your sinking diver diving down in the water to come up and try and get those rings. It's an old game we used to play. You used to push buttons and you used to try and get the rings onto the post there. But in any case, you can search for Cartesian diver. This is a very simple experiment that you can do with little things in your own home. Straws, rubber bands, a little bit of water that I spilled all over my floor. I'm stepping in it now. But in any case, it creates a nice little demonstration that centers around buoyancy and density and how much more dense things sink to the bottom, right, in the ocean. Hopefully you enjoyed yourself. Hopefully you did some sciencing over the weekend. If not, here's the start to your week. You can science, making a Cartesian diver, maybe save up some of those soy packets because, listen, they're packed loaded with sodium, and that's not good for you. If you squeeze, right, real hard, there goes my diver, and half of my packet, right, one sank, one didn't. I'm squeezing. One goes and one doesn't. All right, folks, there's your lesson for today. Go outside, have some fun, do some sciencing at home. Remember to keep checking Facebook, Instagram, TikTok. Our webpage is still full of materials and still full of resources for you. Just find a way because we're still here for you and we're providing you with resources. Like us, share us, most importantly, support us, support one another. Hope you have a great Monday. I'll see you again through the week. The Wild Palace have some really cool stuff lined up for you for the rest of the week. I'll see you Friday.